This is a practice exercise video solution. For this practice exercise, we'll get started with the supplied dataset, shape optimization. Even though we haven't learned it yet, we're going to take a look at creating a shape optimization simulation study. So to get started, we want to go to the simulation workspace, and from the new study type, we want to select shape optimization. Once we select the study type, we want to verify the material. In the case of a shape optimization, the material isn't going to matter as much as it does in a generative design, because we're only looking at load paths and not necessarily at the deformation or safety factor. Next, we want to apply constraints. I'm going to be using a fixed constraint in this upper right pin and say OK. Then I'm going to rotate to a top view, rotating my model around like this. Then I want to begin to apply some loads. I'm going to use a bearing load. I'm going to rotate this slightly and place the bearing load on the inside. And I want to rotate this around so that it's pointing at the minus 150 degree angle. I'm going to change the unit type to pound force. I'm going to give it a 500 pound force. Once again, we're looking at the load distribution, not whether or not this design will survive this type of loading. Once again, we're going to apply a load. In this case, we'll use a bearing load one more time. I'm going to rotate back around to the top, and this one is going to be rotated to 30 degrees. Once again, I'll change to pound force, and I'll do another 500 pound force and say OK. Now that we have those different areas, we need to move on to preserve regions. We're going to pick a centroid location, and then we want to preserve a certain amount of this location. So we'll add 20 millimeters, and we'll say OK. Then using the marking menu, we're going to repeat this process. When we select an edge, we'll need to dictate the extrusion distance, but if we select a face, then we'll be able to easily capture just the area of interest. We'll do this one more time, making sure that we do preserve all these regions. This one we're going to increase a little bit more to 25 millimeters and say OK. I'm going to navigate back to a home view and take a look at the optimization criteria. By default, it's going to be going to target mass less than or equal to 30% of the current value. This can be changed after the fact by adjusting the color bar, so we're going to leave these settings as is, and we're going to solve the simulation study. Note that shape optimization cannot be solved locally. This must be done on the cloud. It's only 5 cloud credits, but it does require you to use some of those credits to solve the simulation study. If you don't want to use cloud credits, you can simply follow along with the video and take a look at the results. We can see here that the simulation study failed. It tells us that it failed to solve, and if we take a look at the details, we can see that it finished with errors and the cloud credits will be refunded. So it was able to create a mesh, but it did fail to solve, likely because some of our values. What we can do in this case is we can make some adjustments to our study settings to ensure that we do get a solve. For example, if we go back to our criteria, we set this at 50%. And if we go back to some of our loads and we take a look at the first bearing load, we're going to modify this to 250 pounds instead of 500 pounds, and then try to solve it again. You can see here with the slightly modified settings, we now have a result. However, with the result, the 3 areas are detached. One way that we can modify this is by reducing the target mass. We can see here that we get to a point where we start to see the load distribution and a potential area where we can remove some mass. With a design like this, however, we are seeing that most of the mass is going to be required. So this tells me that I don't want to cut a hole all the way through the part, but I might be able to remove some of the material from the top and the bottom, making more of an I-beam shape. If we want to carry these results into the design workspace, we can promote them by using the results tools to promote and moving this into the design workspace. From here, the mesh can be used as a reference, either by using a mesh section sketch or by simply lining it up visually and manually creating a sketch to remove material. For this example, I'm going to start a new sketch on the top face, and I'm going to use my line tool to begin drawing a line that's parallel to that upper edge. You see that it's automatically applied. Then I'm going to use my circle tool. I'm going to bring a circle out until it hits that, here as well. And then for this last one, I'm going to draw a circle that is 60 millimeters in diameter. From here, I'm going to go back to my line tool, and I'm going to go from the center point of these two circles to the center point of this one as well. Lastly, I need to apply some dimensions to these larger sections, and we'll make them 55 millimeters. We'll make this one the same. And then I want to give an offset dimension here, and I'll use a value of 8 millimeters, and then we'll finish the sketch. We can now use this sketch section to create a small extrude, in this case -5 millimeters. Then we can mirror it to the other side. We can also just reuse the sketch, in this case, create another extrude. We'll select our profile, but this time instead of starting from the profile, we'll start from an object here, and then we'll extrude it 5 millimeters on this side as well. Expanding the bodies and hiding our mesh body in our sketch, you can see that we've now removed some material. And this model is now ready to go into simulation, maybe have some small details added to it, such as fillets or chamfers, and validate whether or not it can hold up to the loads and constraints that we had applied. At this point, let's go ahead and make some saves, and then we can move on to the next practice.